Have you ever wondered why an amplifier, designed to amplify only alternating current signals, might still show a small, steady voltage at its output even when there is no input signal present? This common phenomenon can introduce errors into your circuits. DC offset voltage in inverting amplifiers is primarily mitigated by a combination of careful design techniques, including balancing input impedances to compensate for input bias currents, employing external nulling for input offset voltage, and utilizing AC coupling capacitors. These methods work to either cancel out or block unwanted direct current components from appearing at the amplifier's output. The core reason for DC offset voltage stems from inherent imperfections within the operational amplifier itself. Two main culprits are input bias currents and input offset voltage. Input bias currents are tiny direct currents that flow into or out of the op-amp's input terminals. If the resistances seen by these two input currents are unequal, they will create different voltage drops, leading to an unwanted differential voltage at the inputs. Input offset voltage, on the other hand, is an intrinsic small voltage difference that exists between the input terminals, even when both inputs are theoretically at the same potential. Both of these factors are amplified by the circuit's direct current gain, resulting in a noticeable direct current component at the output. To effectively manage these issues, several practical steps can be taken. For input bias current compensation, place a resistor in series with the non-inverting input. The value of this resistor should be approximately equal to the parallel combination of the feedback resistor and the input resistor connected to the inverting input. This balances the impedance seen by both input terminals, causing the voltage drops due to bias currents to largely cancel each other. For input offset voltage, many operational amplifiers include dedicated null pins that allow for the connection of a potentiometer to fine-tune and minimize this offset. Alternatively, an external offset cancellation circuit can be designed using another operational amplifier. When only alternating current amplification is desired, AC coupling capacitors can be strategically placed in series with the input signal or at the output to block any direct current component while allowing the alternating current signal to pass through. It is important to remember that even with the most careful compensation for input bias currents, residual direct current offset may still exist due to factors like temperature drift and component tolerances that can alter resistor values or op-amp characteristics over time. The strategy of balancing input impedances is particularly effective because it ensures that the direct current voltage drop caused by input bias currents is nearly identical at both the inverting and non-inverting terminals, forcing the differential input voltage closer to zero and minimizing its amplification. By understanding the origins of direct current offset and applying these mitigation techniques, engineers can significantly reduce unwanted direct current components, ensuring that inverting amplifiers accurately process alternating current signals and deliver the clean, precise amplification required for sensitive electronic applications.